name of the Linux debugger is GDB, the GNU debugger. Now, it's a source code debugger. That is, it knows how to track the source code of a program while executing the code generated from it. And it can do this for several languages, including C, C++, Fortran, and so on. But it has some low-level commands and can be used to debug assembly language as well. I'm going to demonstrate it with a very simple program. No mainline is included. It's a simple assembly language function. To be able to control it with a debugger, the G option must be used. That causes the source code and the symbols of the original program to be included in the object in such a way that the debugger can use it for display as it steps through the code. The object file is converted into an executable file by GCC with linking it to the C library. The program to be used is a version of the greatest common divisor example from a previous lesson. The entry point is named main in this version and is declared this way as a global name. All this is required by the C library this links with. The program contains two constant values, and in a loop it determines their lowest common denominator. Now, I'm not going to trace it in detail through to completion, but I'll show you how it can be done. When you enter a debugging session, you're looking for something, and GDB provides you with the tools to walk through the code and find that something. I'll show you some of the basics for doing that. To run the program under control of the debugger, just run the debugger with the name of the program as its only argument. Now, you can't just run the program or it will run to completion. So the first thing you need to do is specify a point at which you want it to stop. If you use main as the breakpoint, the program will run only up to that point. Now notice that the information you get about the breakpoint, it includes the address and the line number in the source code. Now, when you run the program, it halts at the breakpoint. It displays a line of code from the source file. This is the line that will execute next, not the one already executed. That's important to remember if you want to check the status of things while you're stopped. The next I command is short for next instruction. Each time you enter it, exactly one assembly language instruction executes. Notice that the display of the upcoming instruction includes displaying the comment. At this point, the values should have been loaded into the EAX and EBX registers, and you can use the info command to look at the registers. The name of each register is displayed, followed by the value it contains in two forms, base 16 and base 10. The value of the flag register is also displayed along with the list of the flags that are set. At the bottom are the values of the segment registers, which are not used in the 32-bit programming model that we've been using. You can also look at the values in the floating point registers. As you can see, for this program, they're all empty. You can use info to look at several different things. You can enter help info to get a list of the things that you can look at. The type of things you look at depend on what you're looking for and what you're debugging. Some of the info options are for general debugging, and some are only for specific languages. And of course, info is not the only command available to you. Lots more commands are available to you than I have time to show you. You'll need to try it for yourself, and you can get information from the man page of the debugger, and there are lots of documents and tutorials online that list them all. But the only way to really learn how to use the debugger is to experiment with it, to see how it works, how it shows you what you want to know, and how you can use it to control your program. But there is one more important point I want to make. If your program crashes when it runs, you can use the debugger to see what caused that crash. In Linux, whenever a program crashes, that is, whenever a program terminates abnormally, a core file is dumped. Into the default directory, an image of the executing program is written to a file named core. You can use the debugger to perform a post-mortem on that file. You simply start the debugging session as normal with the name of the core file added to the command line. The program loads halted at the point of the crash, and you can examine the instruction and the register contents and anything else that contributed to the crash. I personally find this to be the most handy feature